Hello friends, welcome to our channel. In this lecture, I would like to explain another example based on the uniaxial condition. See here, that is example 6, a short reinforced concrete rectangular column of size 300 by 600 mm subjected to a factored load, that is axial compressive factored load of 1500 kN and a factored moment of 300 kN meter, adopting M20 grade concrete and Fe 415 steel. So first of all, take down the given data. Okay, so what is the given data? So that is the rectangular column of size 300 by 600 mm and axial factored load, that is Pu will be equal to 1500 kilonewton and factored moment will be equal to 300 kilonewton meter. So adopting M20 grade concrete, which is FCK, characteristic compressive strength of the concrete, will be equal to 20 Newton per mm square, and Fe 415, that is Fi will be equal to 415 Newton per mm square. So all these are the given data. So what is the difference between the previous problem, what I solved in the example 5 in our channel, and today's problem means, so they will give an unsupported length of some 3.3 meters and they will given some dimensions like some 300 to 400 around. I don't know whether what is the dimensions particularly. See here, at that time in the last example we have the condition of it will be braced and just the directly mentioned design a reinforced concrete, so they didn't mention there that is whether it comes under the short column or long column. So based on that you have to find the short column or long column, means L by D less than 12, it will be designed under the short column. But here you clearly see the difference between this particular example and previous example. So they directly mentioned that this is a short column, so you don't need to check all the condition like E minimum, E eccentricity, all the things. And again we have to check the condition one more thing, E minimum by D will be less than or equal to 0.05. So if it will satisfy this condition, you can design according to axially loaded. If it will be greater than means, then you can design based on the eccentrically loaded columns. But here they will directly mention that this column have the factored moment of 300 kilonewton meter along the major axis, means along the major axis it have the factored moments, means one more additional moment will be developed. See here, so this is the column. So we people know that exactly center there will be axis of that particular column. So what is the meaning here? Axially loaded column means, what is the meaning here? Axially loaded column. So exactly the load is passing along the axis. So like this, the load is passing along the axis. That is the meaning of the axially compressive factored load. And again, so that is of some 1500 kilonewton and a factored moment of 300 kilonewton meter, means some one more additional moment is developed here. So if they will mention the moment only along one axis, so this is comes under the uniaxial column. And in the question itself they will clearly mention that moment along the x-axis it will be equal to some x and moment along the y-axis equal to some y. At that time you have to design that particular example based on the biaxial condition. Okay, so you please remember the difference. I will explain this type of model also in our next example, but here according to our given question, so there is an axial compressive factor load and one more additional moment is developed. So if this additional moment is not developed means, what they used to given means at some eccentricity there will be some factor load is developed, so moment equal to P into E, like that also you can take down moment value directly. But here in the question itself they will clearly mention that moment will be equal to some 300 kilonewton meter, like that. So based on this condition you can design this type of model based on the uniaxial conditions. Okay, if the moment is given along x and y axis, then use it to design the type of models based on the biaxial condition. Okay, so already we solved all the examples up to now, up to example 5 in our channel based on the special Indian standard 456 2000. But the design of this type of eccentrically loaded columns means uniaxial and biaxial columns very difficult based on the Indian standard IS code book. So therefore Here we are using special publication 16 charts, means SP16 charts, to solve this type of models. I will explain that also. See here, so take down the given data. After that, see the SP16 chart. The SP16 book. So please download this SP16 book. So this is the SP16 book, Design Aids for Reinforced Concrete to IS 456 to 1978. So this is the special publication. So download the special publication 16 charts. So you see here, that is the starting page. So you can download directly SP16 in your browser. So each and everything they will clearly mention that list of charts like FC K 50 Newton per mm square. I will explain according to the charts. So I will directly moving to the charts like 133. See here, I am just taking one chart like chart 28, compression with bending, rectangular section, reinforcement distribution equally on two sides. If you observe here, what is the given data? Fy will be equal to, so Fy will be equal to 250 Newton per mm square, and d dash by d ratio will be equal to 0.10. I will explain what is d dash by d. And here the reinforcement equally on two sides, means this side it will be 4 and this side it will be 4. So equally on two sides means whenever in our question they will mention that Fe 250 steel, and if you will get d dash by d ratio will be equal to 0.10, means at that time you have to use this type of chart. And if you want to provide reinforcement equally on both sides, for example, if you move to the next chart, if you observe very clearly, what is the difference between the previous chart and this chart? So there is d dash by d will be equal to 0.15, means what is d dash here? If you observe clearly, d will be taken like this and b will be taken like this. So according to our column sizes, this will be 600 and this will be 300. Okay, and what about this d dash? D dash is taken from the center of the cover diabar to the extreme fiber. Okay, means, so already we people know minimum clear cover we have to maintain 40 mm for any type of columns. Then I am assuming some 20 diabar. So at that time I am assuming some 20 diabar, means I am taking center of the diabar, like diabar 20 will be equal to center of the diabar, means clear cover d dash is the effective cover, means 40 plus plus 20 by 2, so which is 50 here. Like that we have to assume clear effective cover according to the condition. Okay, then you can solve the ratio d dash by d. So around 600, so how much you will get? 50 by 600 means, so I think the value will be 0.08, means 0.08 means which is lesser than 1. So there will be the graphs of 0.05, 0.10, 0.15. If you will get exact value, means take down the exact value. If you will get any middle value like 0.05 to 0.01, in this case you can move to the next value which is near higher value, that is 0.01. Okay, if you will get 0.10 above, means take down the charts of 0.15. I will explain that also while solving the problem. So I am just showing the small indications about the particular chart in what we have to select. If you observe this one, so this is the d dash by d ratio of 20. Okay, and reinforcement equally on both sides. Like that, if you see all the different charts here, this chart will based on Fi 415, and the ratio will be d dash by d will be equal to 0.05. So based on that, you have to select the chart whether you provide the reinforcement equally on all the faces or else opposite faces. See here, if you observe this chart related to Fi 250, and in our question already it will be mentioned that Fi 15. So therefore I am searching for the 415. See here, this is the chart related to 415. Okay, which is chart number 43 and 415 chart. Okay, Then here the reinforcement is provided equally on all sides. If you count 1, 2, 3, 4, 5, 6. Here 1, 2, 3, 4, 5, 6. Here 6 side, here 6 side. Like that, the reinforcement is equally on all sides. That means 4 sides. So before going to design a particular problem, you please choose any one condition, whether I have to provide the reinforcement only on one side or else equally on all sides, like this, or else like this. Okay, equally on all sides. So that is our first condition. In the question itself they will mention clearly that you have to design for that particular case, means you have to take according to the question. So in our question it is not mentioned, therefore here I am choosing the condition reinforcement equally on all four sides. So this condition, so this side 6, this side 6, this side 6, and this side 6, so all sides 6 6. So that is reinforcement equally on four sides, which is 6. Means here the model is given for 6, so like that you will get equal side like 7 7 8 8, like that, whatever the ratio which is suited for equal on all four sides. Okay, and first check the d dash by d ratio. So our column sizes will be 300 by 600, means here small dimension which is 300, larger dimension which is 600. Okay, so I am arranging this one. Why? Because it is not particularly for 6, it is equal on any basis. Okay, then first of all select the d dash value. So here itself I will take down that one. So what is the d dash value? I told d dash is the effective cover. D dash is the effective cover here according to the chart, and minimum clear cover we have to maintain per particular column will be equal to 40. 40 clear cover minimum for columns will be 40. Then I am choosing the diameter bar of 25. If I choose some 20 bar means, and I will take center of that bar 50 means, after getting trials we will get some extra bar. For example, if I will choose 20 dia bar, and by placing I will get 25 means your clear cover will be lesser than what you will take. Therefore, what I am taking means I am taking 25 minimum clear cover in my condition for safety purpose. Then what is your effective cover? 40 plus 25 by 2. If you take down this one, 12.5 times means 52.5. For example, if I am assuming 25 dia bar for our case means it will be okay. Maybe there is a chance of assuming 32 dia bars also. At that condition we can't say exactly. Therefore, I am round off this value to any particular near value which is 60 mm. So therefore, I am selecting 60 mm. If you want you can choose 52.5 divided by 2. But in the end you please check the condition whether we are satisfying according to our condition or not. Okay. So therefore, I am choosing 60 mm. And I am going for the ratio d dash by d will be equal to 60 by 600. So almost all 6 and 6 means you will get 10 times, which is 0.10 chart. So this suited according to our condition. For example, if you take some 52.5 divided by 600, at that time you will get 0.08 only, so which is the same value, no problem. So maybe the dimensions will be lesser, like 500 around means, at that time you will get another curve like this is d dash by d will be equal to 0.15. So please select this chart. So I will explain all the things here clearly. Okay, then after getting the things, there will be two non-dimensional parameter. One will be here, that is pu by fck bd and mu by fck bd square. So first you find out these two values, pu by fck bd. So already you people know that pu will be given in the question, that is axial factored load, and fck bd. So first find out these two non-dimensional what is given in the data. Then based on that, this is a chart of related to p by fck, which is taken from 0 to 0.26. So you can relate the pu value and mu value, then wherever it will relates you will get that p by fck. So here p is the percentage of steel and whatever the value obtained here, so you can relate that one and find out the side. So whatever the p value obtained here, you substitute in this formula, directly you will get the area of the steel value. So I will explain that one step by step. So here your y axis related to pu by fck bd. So please check that one. So that is non-dimensional parameters. So that is equal to Pu by FCK B into D. So what is Pu? Which is given 1500. Okay, and the FCK is 20 in terms of Newton. So therefore I am converting this kilonewton in terms of Newton, that is 10 to the power of 3 into what is the B value here? B value is 300 and what is D value? That is 600. If you simplify that one by using your calculators, so there is a chance of getting 0.416. You please check this value, then for that value only you have to provide. So for me it will getting 0.416 and again mu by FCK BD square. So what is mu here? Mu will be given 300. So in terms of kilonewton meter to Newton to millimeter into 10 to the power of 6. For kilonewton it will be 10 to the power of 3. For meter to millimeter it will be 10 to the power of 3. So you will get almost the value is 300 into 10 to the power of 6 by FCK will be 20 into B value is 300. D value is this one 600, which is 600 whole square. If you simplify this value, then definitely will get this value 0. Sorry, this one will be 0.138. 0.138. So your Pu by FCK BD value will be equal to 0.416 and your Mu by FCK BD square will be equal to 0.138 and your D dash by D ratio already explained, that one will be equal to 0.10 only. So 0.10. So what I choose in this chart. So here I am showing that one very clearly. See here. So what is your Pu by FCK D value? So that one will be equal to 0.416 and your Mu value. So I am zooming this one. See here 0.138. 0.138. Okay. See here. So based on this graph, I am going for the approximate values. See here, this is 0.4 and 0.5. So our value lies in between these two. And again there will be the digits divided for two values, means 0.4, 2, 0.4, 4, 0.4. So starting value will be 0.4, 0.42, 44, 46, 48, 5. Like that every two decimals it will be, I am taking that one. If for every two decimals it will be two decimals, I am increasing the value according to this graph. Then here there will be one digit. So 0.1, 1, 2, 3, 4, 5 and again 1, 2, 3, 4, 5. There will 10 digits will be there here. Therefore for every one decimal I am dividing 0.11, 1, 2 like that, 0.13 and here it will be 0.14 and this one will be 0.15 like that. So this one will be 0.16, 0.17, 0.18, 0.19, 0.2. So that like that I am dividing this one. So don't confuse this one. So according to that only I am seeing here 0.138 means 0.1, 1, 1, 1, 2, 1, 3 and 1, 4. So your value lies between 0.13 and 1, 4 means somewhere here 138 means somewhere here and again this 0.416 will be 0.4 and 0.42, means in between somewhere here like that. Okay, so if you relate these two things, means so it is better on a paper you please keep some scale and draw a line like this and draw a line perpendicularly like this to this value. Then wherever it will relate, take down that value. So here it is not possible to take the scale, so I am going like this. I am going for approximation. Okay, and again I am going for like this. So it is better to take 0.4 value, 14 value also directly. For 138 I am choosing in middle, means so this is the curve which is related to, so this is 0.12 and this is 0.10. So there is the curve passing 0.12 and it is relating below 0.10 and above 0.12. So you can choose P by FCK will be equal to 0.11. So somebody will take 0.12 also, no, you can relate that one and go for this one. So maybe you will get area here, that is also safety only. So here I am choosing P by FCK will be equal to 0.11 according to my condition. Like that you have to choose the graph based on the non-dimensional parameters. Okay, sometimes by using this P by FCK also you can relate this one. So in the biaxial condition I will explain that also. So here according to this condition you will get your P by FCK will be equal to 0.11. Okay, or else you can choose 0.12 also, no problem. Then if you take down any one value, so for safety purpose you take higher value also, no problem. So if I want a P value, so I am relating that one with 0.12 into FCK. So what is FCK is given? 0.12 into FCK is 20 is given. So 2 into which is 2.4. So your percentage of the reinforcement, that is P value, will be equal to 2.4. If you take 0.11 means how much you will get? So 0.11 into 20. So maybe you will get 2.2, means somewhat lesser percentage. No problem. I am providing for higher percentage only. It is safe inside. Then after obtaining this P value, then what is left in the chart? You please observe in the chart. So what is left in the chart? So which is area of the steel will be equal to P by 100. So here you can find out that AS will be equal to P into BD by 100. What is P obtained value here? 2.4 into B value is 300 and D value is 600 by 100. So you can find out this value 6318 times and again 2.4 times. So if you find out that one, how much you will get? That one will be equal to 300 into 6 into 2.4. So around you will get 4320. That is your area of the steel for your particular problem. Maybe somebody will choose D dash will be somewhat lesser what I take, then for that persons the graph will be maybe somewhat different and you will get somewhat different percentage. So based on our suitable conditions you will get the area of the steel according to the SP16 charts. This is the way for finding the chart non-dimensional parameters based on the charts. Here you will get directly AS. For according to IS standards, there will be one formula for the axially loaded columns. PU equal to some 0.4 FCK like plus 0.67 FIAC. So that is somewhat complicated for this type of problems. That is the reason I am using SP16 to solve these models. Okay. So after obtaining 4320, then go for the trials. So in what way you have to find the number of bars along with the what dia you have to choose. So for first trial I am choosing so equally on all faces. What is our condition? The reinforcement is equally on all faces. If the reinforcement is equally on all four faces means, so what are the bars generally we have to use at that time? Means at that time 4 bars also you will get equally on 4 sides, but the column dimensions are higher here, so therefore 4 bars are not suited. Then see the condition one more. If I use 6 means equally only on two faces, not on all faces, then I am going for 8. 8 is also suited equally on all faces. Then I am choosing with 8 bars of, so I am coming from 20 dia bar. If it will be higher means I will go to the lesser value. So it is better to find 8 into pi d square by 4. Like that, if you find means, if you simplify, already I simplified, I will get 2512 mm square. So here the required value is 4320 and the obtained value is 2512. So therefore it is not suited. And again go for 8 to 25. Then you will get at that time it will be equal to 3925 mm square. Okay, but it is very near, but not is required. Why? Because it is lesser than this one. Then I am choosing one more bar, like 8 bars of 32. So at that time how much you will get if you provide, I don't know, I will check that one. So 8 into 3.14 into 32 whole square divided by 4. So here you will get 6430. So it is suited only, no problem. If you want, you can check minimum reinforcement on a particular column and maximum reinforcement on a particular column. Then check the trials of another number of the bar. Like for example, if I am choosing 10 bars, like this, I am choosing 10 bars. So here reinforcement is not equal on all the faces. And again, if I am choosing 12 bars, like this, so I am not fitted here according to the sizes. Just I am showing the rough indication. So it have to actually it have to provide all the things with this same spacing, equal spacing, but I am just seeing according to the logic 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4, but it is suited. 12 bars will be okay for equal on all faces. Okay, so check with 12 bars of 20 dia bar again. Then how much you will get? 12 bars of 20 bar is 37618 mm square. It is also lesser the value compared to the required value. Again I am going for the next value, which is 12 bars of 25 dia. How much you will get? If I simplify it means I will get 5887.5 mm square. Means observe here clearly. So this value also suited, this value also suited. Means both the values, means we have to provide 8 bars of 32 dia also okay, 12 bars of 25 dia also okay. If you have to provide the section economical means, then choose this one, 12 bars of 25 dia. And is it okay for you for providing conveniently 8 bars on a particular column means, then choose this one. Okay, according to the condition we have to choose what you have to fit. So whatever you want to choose means you can choose that one. Then after providing this one, so here I am choosing this one, provide 12 bars of 20, 12 bars of 25 dia. After choosing this one, then we will go to the next step, providing lateral ties. So already we solved so many problems based on this lateral ties. So directly I am going this step. So each and every step by step along with the page numbers of the IS code I explained that one. So the first condition is it does not less than diameter by 4. So what I told you, so I am choosing the diameter of some 25 mm by 4. If I choose higher dia bar also you will get higher stirrup only, like some 6.25 around. If I choose some 8 bars of 32 also, you will get dia bar here 32 divided by 4, you will get above 8 only. That is the reason you calculate according to this condition here. So here 6.25 and second condition is it does not less than 6 mm. Out of these two provide higher value. So this is the higher value 6.25 and the next bars to 6.25 is 8 mm. So therefore we are providing the lateral tie of 8 mm. So if you are choosing any other bar like 8 bars of 32 or any other bar means, take down that longitudinal dia bar by 4. And pitch, which is spacing in the beams, but here we used to call pitch. And the first one is least lateral dimensions of the column. So least lateral dimensions is here 300 mm. Okay, so there is a column size of 300 by 600. So least lateral dimension is 300 mm. And second one is 16 times the diameter of the longitudinal bar. Okay, 16 into what is the diameter of the longitudinal bar we are taken here? 25. So 25 into 16, around how much you will get? So I am simplifying that one. So for me it will getting around 400 mm. And what is the third condition? 300 mm. So whichever is least. So here both the values are same. Therefore least value is 300 mm. Means provide the lateral tie of provide lateral tie of 8 mm dia bar with 300 mm pitch. So this is the procedure for finding lateral tie and pitch. So if you have any confusion on this particular topic, means you please watch the previous videos. There I explained each and everything according to IS 456. I shown the page numbers and condition where it will be given in our code book also. Okay, so that is the repeated topic. That is the reason I am taking directly here. Then after that, go for the detailing of the reinforcement. There also, so already I explained all the cross section, elevation, all the things. Here just I am showing the cross section of that particular diagram. So here, so this is the cover, this is the overall dimensions taken from here to here, that is 600 mm, and here to here, means which is cover will be taken from the center of the dia bar. This is the lateral tie. Okay, this is the lateral tie of 8 mm still. And so I am giving the dia bars like equally on all faces. So 1 2, so provide spacing according to the standards only. So that spacing also I explained in the very starting lecture where I covered the introduction part. So or else you can follow the specifications according to the Indian standards. Okay, so all dia bar sizes are equal. So all are in same line only. So here also it will be 2. So if according to the spacing it is not suited, means then provide 8 bars of 32 dia only. If it's suited, means you can provide like this. Okay, check the specifications. Okay, then so for example, if the 4 bars, it will be tie like this, it will be started like this, and again, for example, what I am telling means there will be bars like this, means first it will be taking tie like this and it will cover all the bars, and again it will be round off like this, and the remaining bars for center bars again taken like this. So anywhere you have to take, so this bar is included here, and again you have to tie like this. Okay, for middle one. And again for this one it will be like this. Sorry, anywhere you have to take down this one, and again this one like this you have to take round off. So I mean giving the indication like this for this one like this. Okay, so this is the way of giving the detailing for 8 bars of 25 dia. So if you want elevation, you can show the elevation and give the pitching details also, that is 300 mm around. So somebody will take 8 bars of 32 mm dia also, At that time I will show you roughly here. So this is the dimension and this is the lateral type. So for 8 bars it will be very easy to provide here. So like this, 2, 3, 4, 5, 6, 7, 8. So spacing will be equal for all bars, bar to bar. So if you want to give means first like that only. So covering all the outer bars, 4 bars, and for internal bars, for these bars you have to give like this. Okay, so taken from starting here to ending here. Like that also you have to provide for 8 bars of 32 dia. So this is the cross section. So for previous problem I also shown that cross section and elevation. So for this one I am stopping up to here because entire procedure will be same. So I hope you understand this lecture. If you really like this video, please like this video, share it to your friends and subscribe our channel. Thank you so much.